what I have here is homework assignment 10.3. I'm going to do 3 examples that would be helpful, I think, maybe to get you started if you still don't feel confident doing problems like this. I'm going to do number 9, number 17, and number 25. Starting at number 9, it says each regular polygon has radii and apothem as shown. Find the measure of each numbered angle. Okay, so I've got a regular quadrilateral here, in other words, a square. I want to find the measure of angle 4, 5, and 6. We'll just go right in order. So starting with 4, in a regular polygon, since this has 4 sides, when I have the center and all my radii drawn, it breaks this up into 4 congruent angles here in the center that, if I add it up, make a full circle, 360 degrees in a full circle, 4 congruent angles to divide it by. So 360 divided evenly 4 ways leaves me with 90 degrees. Each of those angles inside my square is 90 degrees. So that's the measure of angle 4. Moving on to angle 5. If I draw an apothem, also an altitude from my center, what it does is it bisects this 90 degree angle that I had, which makes this angle half of 90 degrees, or 45 degrees. So the measure of angle 5 is 45 degrees, as well as the measure of this angle in here, 45 degrees, which will help me find the measure of angle 6. Here I have a right triangle, so my 90 degree angle, and in a right triangle, the other 2 angles always add up to 90 as well. So 45 plus what equals 90? 90 minus 45 leaves me with 45 again. The measure of angle 6 is also 45 degrees. Heading down to number 17, it says find the area of each regular polygon. Round your answer to the nearest tenth. The area of a regular polygon is 1/2 perimeter times apothem. And each of these are given a side, so that makes it easy to find the perimeter. For number 17, 1/2. My perimeter, each side is 18. In this case, I have 1, 2, 3, 4, 5, 6 sides. So my perimeter is 18 times 6. To find the apothem, I'm going to need to draw in my center. Let's draw the apothem. Here it is. We can label it A if we want to. And to help me find that, I'm going to draw some radii as well. If I were to draw in all my radii, what I would find is, I guess we'll draw all of them. If I were to divide 360 by 6 to find the measure of each of these angles, 360 by 6, I would get 60 degrees for the measure of any one of these angles, 60, 60, etc. When we drew the apothem, it bisected that angle. And so in here we have half of 60, which is 30. So what I have is a special right triangle, which I'll draw larger out here. We have a 30 degree angle down there, 60 degree angle here. This is my apothem, and we know this side, because when we drew the apothem, it bisected this side. Cut the 18 right in half. Half of 18 gives me 9, so I know that side. When I'm finding a side using one of my special right triangles, put the ratios around the outside. So across from the 30 degree side is x. Across from the 60 degree side is x times the square root of 3. Across from the right angle, my hypotenuse, is 2x. Use the side you know to solve for x. In this case, very easy. X is 9. And then go plug it in to find the length of the side you want to know. Plugging it in here, we find that my apothem is 9 times the square root of 3. So that'll finish off our area equation, 9 times the square root of 3. It says round your answer to the nearest tenth, so all you need to do is multiply all of those numbers and cut it off at 1 decimal place. Moving on to number 25. Find the area of each regular polygon with the given radius or apothem. If your answer is not an integer, leave it in simplest radical form. So, if you had to choose, it's nicer if they give you the apothem. In number 25, we're given a radius, which means we need to find a couple measurements. For the area of my regular polygon, that is, once again, 1/2 the perimeter times the apothem. I don't have either of those in this case, so what I am going to do is going to draw my apothem. We can call it A if we would like. This side over here is 4. It's pointing there, but maybe I'll put the 4 over here. And I also want to find the length of a side so that I can find the perimeter. So maybe we'll call this S because it'll help me find the length of my side. What I've got is a right triangle. In this unit, when you got a right triangle, it's going to be one of your special right triangles. So I need to know the measure of at least one of these angles. Well, I guess the quickest way, this is a triangle. If it's regular, all my angles are the same. So each angle around my triangle is, angles in a triangle add up to 180. Divide that evenly by 3. Each angle is 60 degrees. 60, 60. And this angle up here is 60, but when we drew the radius, what it did is it bisected this angle. It cut that 60 right in half, made that angle 30 degrees. So I've got a 30, 60, 90 triangle. I guess I'll put the 60 in. Don't need to redraw this one bigger. When we're using our special right triangles, put the ratio around the outside. Across from the 30 degree side is x. Across from my 60 degree side is x times the square root of 3. And across from my right angle, the hypotenuse, is 2 times x. Use the sides you know to solve for x. In this case, it's our hypotenuse. So 2x equals 4. Solving for x just looks like dividing each side by 2. I find that x is 2. So, go back and find my apothem is 2. That's just x. We can plug that into our formula if we want. 1/2. My apothem is 2. And to find the area, this side, S, is plugging in 2. I get 2 times the square root of 3. However, that's not the full length of this side. We just found the distance from this point to where my apothem hits this side. My apothem bisected this side, cut it right in half. So this segment is 2 square root of 3. This length would also be 2 times the square root of 3, which makes the length of this whole side 2 times the square root of 3 plus 2 times the square root of 3 is 4 times the square root of 3. You can combine it just like terms. And if one side is 4 times the square root of 3, I have 3 sides, so my perimeter is 4 times the square root of 3 times 3. 3 sides. And this says leave it in simplest radical form. So what I would want to do with all of this, take the radical, my square root of 3, don't do anything with it, just move it on down and multiply everything else. So 1/2 times 4 times 3 times 2, that would give you 12. 12 times the square root of 3. We were measuring in inches, so you can say inches squared.